We're looking at colligative properties. So a colligative property is a property that will change depending on the amount of solute that is dissolved. If that solute will break into ions, it will affect the solution more, or that property more, than if the solution or if the solute was not able to break into ions. There are 4 colligative properties that you have to know about. The first one is vapor pressure lowering. So vapor pressure is the pressure of the gas molecules hitting the surface of the liquid. So if we look at the pure solvent here, these gas molecules up here would come into contact with the surface of the liquid, and that is what vapor pressure is. So it's the pressure that the gas molecule is hitting against the surface of the liquid. If we add a solvent, or a solute, into our solution, which is represented by these yellow particles, they're going to block the liquid from becoming a gas. So when you add solute, it lowers the vapor pressure because it's not allowing those molecules to become gases. Freezing point depression. So freezing point also goes down as you add solute. So if we look here, remember freezing is the coming together, the liquid turning into a solid. So the molecules have to get really close together. Well, if you put something in between them, the solute, it's harder for those molecules to slow down and become a solute or a solid. So adding solute decreases the freezing point. You have to get to lower and lower temperatures before it actually freezes. Now, boiling point, it's boiling point elevation. The boiling point will go up. So in order to take your liquid and change it to a gas, you have to get to higher and higher temperatures when you add that solute. And if you think about it, it makes sense. If you put a solute in there, it's blocking the molecules from becoming a gas. So you have to give it more and more energy in order to break through. Osmotic pressure, the solute pressure, so the water pushing on the semi-permeable membrane, is what osmotic pressure is. And when you add a solute particle, the osmotic pressure will increase. I am going to include some videos underneath this one that will link you to different places that explain this as well. So if you didn't get my explanation, maybe one of those other videos will help you. But this is the general gist of what you need to know. Boiling point goes up when the solute is added. Freezing point goes down when you add a solute. Osmotic pressure goes up. Vapor pressure goes down. So then the questions will look like this. Which of these would cause the freezing point of water to decrease the most? So the first thing I'm going to key in on is freezing point. And I know it's freezing point depression, which means the more solute I have, the lower the freezing point goes. And since this question is asking me to decrease the most, it wants the lowest freezing point, which would mean it has the most amount of ions or the most solute. So then I look at my answer choices. I have NaCl, which is an ionic compound. So that's going to break into Na plus and Cl minus. So that would break into 2 ions. Whereas C2H6O2 is covalent. So it's a molecule. It's not going to break into ions. So we wouldn't count that as 2. We would only count that as 1. Again, we have NaCl that would count as 2 because of the Na plus and the Cl minus. And then again, C2H6O2 being covalent just counts as 1. So since I'm looking for the most amount of ions, I can go ahead and get rid of the 2 covalents. And then I'm just looking at my ionic. I want the most ions. So it's going to be the 58 grams of sodium chloride that decreases it the most, because that has the most amount of ions. All right, one last question. Which of these would have the lowest boiling point? So I'm focusing on boiling point. I know it's boiling point elevation, so the boiling point is going to go up as I add solute. This time I want the lowest. So if I add solute and I add solute and I add solute and the boiling point's going up, then the lowest is going to contain the least amount of solute this time. So then I go through and I categorize my answer choices. NaCl is going to break apart into 2 Na plus and Cl minus. C2H6O2 is covalent because they're all nonmetals, so they're not going to break apart at all. So we would count that as a 1. NaCl is 2 because it breaks into 2 ions. And then covalent would count as 1 because it doesn't break into ions. Since I'm looking for the least amount, I can go ahead and scratch out the ionic this time because that's going to make more ions. And I don't want more, I want less this time. And then I can look at the amounts to separate the two different covalent compounds. And since I want the least, it's going to be the 31 grams. Please make sure that you reach out through Remind or email or Microsoft Teams with any questions that you have.